so that we can now continue, and then I share my screen. So today's lesson, let's look at the application window. No, haven't I opened another application? Let me see. Okay. So I think, yes, I can see what I need to do. And finally, I can open this. Okay. Okay, so I think we are good to go. So we can now start with this one. Okay, let me share this. Is it visible on your screen? Fancy? Sharon?
Not yet. Yes, it is now.
Okay, so we look at the topic of surface area and the volume of solids. Now, I like teaching this topic. When I look at a solid, I look at its surface area, and then I look at its volume, instead of first of all covering all the surface area of solids, and then I can now go to volume. So I just combine. So it's a solid like a cylinder. Like you can see number A here. We have a cylinder. So what I like doing is I like covering the solid. I look at surface area, I look at volume, then we can move on. So a solid, as you can see here, this one, we have a very good definition of a solid right here. Okay, let me... Okay, so a cylinder is a geometric solid that is very common in everyday life. Okay, but the most important thing that I want to say is it has two ends called the bases. Okay, and the bases are congruent and are parallel to each other. Now, if you look at this solid that you can see here, number A, this is what we call a cylinder. These are the ends, and the ends of a cylinder, we have said they are equal, okay? And they are the bases are always congruent and parallel. So it means they are similar, okay? This one means they are similar and they are parallel. It means now when you look at the cross section, because this part here is the cross section from the base to the base, which is circular, and the cross section here, the cross section is uniform, okay? Or it is equal throughout. That's why we say they are parallel. So the distance across this cross section here is always equal for the cylinder. Now we are told that when you unroll the cylinder, you'll find that the side is actually a rectangle when flattened out. So we are going to look at how that happens. So let me now take you to that's a cylinder. So this in this example here, we can see we are being told to find the surface area of each of the following prisms. Now, as a cylinder cannot always be defined as a prism, because when you come to a prism, we'll see something that is a bit different. So some definitions, they tell you that a cylinder is a prism, but it is not a prism as such. So we are told here the radius is 2.8 centimeters, and the length is the length here is 13 centimeters. So let me share something else here. Let me share something else. I want to share something else here. Can you see this one now?
Yes.
Okay. So now let's talk about a cylinder. So we have said that is a solid that has two parallel, usually circular bases connected by a curved surface area. Okay, so the curved surface area is the one that we are seeing when you open it. It forms a rectangular shape. Okay, so this is our cylinder here. So this one is the radius, this one is the height. Now in that example that we are looking at there, it was called the L. Okay, it was given L. Now length, if it is standing like that, okay, like a tank, the way it is, then we can call this one the height. But if it is not standing, for example, in that example, it was like a pipe, yeah, an example of a pipe. It was laying down. So instead of having the height, you just have the length. So where we have the height, you just replace with the length, and that one is okay. So now, what happens now is the rectangle. When you open, when you cut this solid of ours here, so I want to copy this and I bring it here. I want to copy and bring it here. So as you can see here, that is how we can see the net looks like. So you can see this part here, the top is circular, and the bottom here is circular. So it depends on what the cylinder is. Is it closed? Now, if it is closed, like a water container that is having a top and a bottom, it means that we have two circular shapes. That is one at the top, the other one is here at the bottom. And then we have this curved surface area. The other part is the curved surface area, which you have said when it is opened, it forms a rectangular shape. And this is the part that I was saying now, this one, if it is standing, it becomes the height. But if it is laying down, it becomes the length. It becomes a length. So that is what you would, that's what you would, for example, call this one. It would be the length here, okay? It will look like that. So if it's standing like that is the height, but if it's lying down, this one is the length. Now this part here, top part here, is, remember the top of this, top of the curved surface area is circular. Now when you open a circular part, the circular part is called the circumference. So when you open it, the distance from here all the way to here is the circumference. Now how do you find the circumference? You find circumference by saying 2 pi r. Some people use pi d, but remember d is the same as 2r. So we prefer using the formula of 2 pi r. So I've said some people use pi d, so there is no problem if you use pi d. But the best formula to use is 2 pi r because that one conforms with most of the formulas that we have. And this one is the height. So like when you're finding surface area is something that you can touch. Okay. Now for this cylinder here, which is closed, we have the top part which is circular, which I can touch. We have the bottom part which is circular, again I can touch, and they are similar circular parts. And then you have the curved surface area which you are open to form a rectangular shape. So how do you find the area of a rectangle? Just length times the width. This distance from here to here, which is the length, we have said is going to be found is the circumference, which is going to be found by 2 pi r. And you just multiply by the height or by the length, depending on whether it is standing as if it is straight, that's standing, or it is lying, it is just lying, or it is flat out, not just standing. Like the case of a water pipe, the water pipe is laid down. So this one is now going to become the length. But a water tank is going to be standing. So this one now becomes the height. So to find the surface area, we have two circular parts. Okay. Now two circular parts. How do you find the surface area of one circular part? Pi r squared. But now there are two. So it is 2 multiplied by pi multiplied by r squared. How do you find the curved surface area? We have said we are going to use the formula of, to find the circumference, we have said we are going to use this formula here, the formula of 2 pi r. So it is 2 pi r multiplied by the h. In our case here, multiplied by the h. In the other case, you multiply by the length, which is still the same. So you now add the curved surface area, which is 2 pi r h. Then you get surface area of your closed cylinder. Now the cylinder can also be open. Now it can be open on one side or open on both sides. Now if it is open on both, if it is open on one side, it means the top here, like a water container, like a case of a water drum. It might not be having the bottom here, the bottom circular part here might not be the same the top part. So it might not be having the top part where you need to pour your water. So it means this part is not here. So let me delete it. So it means it looks like that. Okay. So the curved surface area is going to remain, and then we have the part, the bottom here. Okay, we have the bottom here. So it's going to be made by one circular part and one curved surface area. So when we come to finding its surface area, we have only one circular part which is going to be found by pi r squared, and then we have the curved surface area, which is found by 2 pi r h. Okay, the rectangular shapes. Now, if it is open on both sides, okay, like the case of a water pipe, okay, there are no circular parts because a water pipe cannot be closed. Okay, we need water to pass through here. So this part is also not going to be here. So it is only going to be a curved surface area. That's what you're going to have, like the case of a water pipe. So you only have the curved surface area. So when you're finding the surface area, you are only going to include the 2 pi r h only if you want to find surface area of a water pipe. Okay. So there are no circular parts. So it is open. Okay. So there are no circular parts. So it is open. So that is how you are going to find the surface area of that that solid. And in this particular case, we are talking about a solid called a cylinder. We are talking about a solid called a cylinder. So you have looked at these scenarios: a cylinder which is open on one side, open on both sides, and closed. Those are the three scenarios of a cylinder that can be brought. And I think everything is very simple because the examiner is just going to give you everything that you require. Like in this case here, that was here. Let me just come. Let me share something else. Like in this case that we have here, yes, let me share this so as you can see. So like in this case that you can see here, we just have this. So you have given the radius and then the length. Because you can see it is lying down, that's why you've given the length. But if it was standing up, you could have been given the height. So instead of where we have the height in the formula, we just replace with L. So find this one. If it is closed, then you are going to find the area of the two circular parts. Okay, 2 pi r squared. So you have r here, and then 2 pi r L. 2 pi r, instead of 2 pi r h, you're going to have 2 pi r L. So where there is h, in our other formula, you just play with this one here. And then you get your answer like there we have here. So this is how you would do it. So I want to go further than that because I'm sure you can be able to have pi. So in the examination, normally you are given the pi. So for you, it now becomes too easy to solve. So let's go to the other case. Let's go to the other share. Yeah. No, sorry, not this. Not this. I want to go to. I wanted to share this. Okay, yeah. Now, on top here, you can see we have a formula for finding the volume of the same solid.
I cannot see the screen. Yes? I cannot see the screen shared.
I've already shared.
It's not here.
Sharon, I've already shared my screen. Unless there's a problem on your end, I think on my side it is there. Can you see it now?
Yes, it's now loading.
There's a screen that I wanted to share here. I hope that you can see it. So you can see now, service area, just like area is given in units squared. So when you're giving your answers in all these parts here, you give your answer in square units. So if it is centimeters, you give your answer in centimeters squared. So area, whether it's surface area or just a normal area, you just give your answer in centimeters squared. Now, volume is given in cubic units. Volume is given in cubic units. Like I'm just going to explain here. So volume is given in cubic units. Now, for example, you can see the volume of a cylinder. Volume is the content that can get in that cylinder. So it's not like surface area, something that you touch. Volume is what capacity. Capacity and volume, they mean the same thing. The contents that can get in there, for example, you can say water. You can just put some flour inside that bucket. So that is what we call volume. That's what we call volume. It's the amount of space occupied by a solid object. So it is actually about space. So whatever you can put in that space, we call it the volume. Okay. So volume is expressed in cubic units, just like I've said here. So now, volume is found by pi r squared multiplied by the h. Or for a cylinder, you just see the volume of a cylinder is found by base area multiplied by the height. Now, why are we saying now? What is the base of the circle? The base of what is the base of the cylinder? It is circular. That's why we use pi. So to find the base area, the area of the base is circular here. So it is circular. Yeah. How do you find the area of a circle? It is pi r then squared. Pi r squared. So I come here. So you say pi r squared. I'm just copying this formula here. I can just put mine here instead of wasting time doing that. I can come here and put pi r squared. Okay. And then as you can see, then you multiply this one by the height. You multiply this one by the height. So that's why we have pi r squared h. Let me change this one to small letters. Pi r squared h, because it is base area multiplied by the height. The base is circular. So how to find the area of a circle? Pi r squared, then you multiply by the height. So as you can see, area is found in centimeters squared. Area is found in centimeters squared. And then you now multiply by the height. And then you multiply by the height. So if area is found in centimeters squared, and then you multiply by another one, height. So you see, for example, if it was centimeters, the answer now is found in cubic units because it's centimeters, and then the height is going to be given in centimeters. So it is centimeters squared times centimeter, and we get centimeters cubed or cubic units. Cubic units. Now you have to be aware that in the exam, when the examiner is going to be giving you a question, they usually give you a question and they want you to convert your answer. For example, they are going to give you measurements in centimeter, like in this case here. They tell you that the radius is 7, the height is 10. So this was not the volume here. This was not the issue of the volume. I think you're following here, yes. Okay, sorry. The radius is 5 and the height is 10. Okay. So how do you find the volume of a cylinder with the radius 5 and height 10? So you have pi r squared, okay, which is pi times 5 squared. So the radius is 5, and then you multiply by 10. So you get that the answer is this. When you multiply, you get the answer as 785.4 centimeter cubed. So you can be told to give your answer in liters, okay, liters. give your answer in liters. So the examiner, when you are calculating the volume, they will keep on telling you to convert. So you have to ask yourself, how many centimeters cubed make 1 liter? You have to say 1,000 centimeters. You have to say 1,000 centimeters cubed. Centimeters cubed. 1,000 centimeters cubed. They make 1 liter. Okay. Now, when you have such kind of a thing, okay, this one is also supposed to be normal. Okay. So 1,000 centimeters cubed is equals to 1 liter. Is equals to 1 liter. If it is equals to 1 liter, is equals to 1 liter. So you can now convert. So for example, this one, you just divide by 1,000, okay? And then that you get your answer is points. So it is 0.7854 liters. So instead of being now centimeters cubed, your answer now becomes, your answer is now in liters. So the examiner will keep on telling you to convert from 1 unit of measurement to the other. Remember, in our syllabus, we have to keep on converting. So you have to make sure that we understand that perfect. So this is how you define the volume of a cylinder. And the volume of any solid or the volume of anything is given in cubic units. And I think I've already explained that, but you're going to see it as we come to the other examples. Now, then I'm going to take you to another solid. Solid number 2 is called a prism. Okay, a prism. So a prism, there are 2 definitions of a prism that you can see here. Now let me take this second one. It's a 3-dimensional shape with 2 identical shapes facing each other. And that's why you can see they were saying that a cylinder fits that description. These identical shapes are called the bases. Okay, a base can be triangular, square, rectangle, or any other polygon. A polygon is a many-sided figure. The other faces, they can be parallelograms or rectangles. So I'm going to take you to another share so that you can see that, and then we can come back here. This is our working space. Then we can now do our working here. So we come, we continue sharing our screen. If you don't think that you have seen the screen, it is good that you confirm that you have seen the screen. Once we are here, so I hope you can hear, you can see the screen perfectly. Sharon. Sharon.
I can see. It is clear.
Okay. So if I shared, you don't see, just mention it. So I'll be assuming that you are seeing it. So unless you have a problem with the network, I think everything is okay. So okay. So let's continue. So a prism, you can see, is a solid with uniform cross section. Now these are the parts that we call the edges. This part here and this other part here is what we call the edges. And as you can see, they have a definite shape. Okay. This one here is also a prism. This shape here is a 5-sided figure. This one here is a 6-sided figure. 6-sided figure is called a hexagon. A 5-sided figure is called a pentagon. Excuse me. Now, we have said the other shapes can be, for example, this one is a rectangle. This one is a rectangle. So the other shapes here, so you have a pentagon, pentagonal edge, or what we call the basis. But everything else, these ones here, they are rectangles. Here, they are also rectangles. So you have an hexagonal edge, or hexagonal basis. Everything else is rectangles. So they keep on changing. They keep on changing. They keep on changing. We've been given the measurements here. So I'll use those measurements after I now come here and share our last yes. Let's come here and then we see. Let's come here and then we see this one. Okay. So we want to see a prism. There are a number of prisms that we have here. So like this one, we have found this one is a 1, 2, 3, 4. This one is a 6-sided figure. Okay, this one is a 6-sided figure, like the one which we had in the other case. It's a 6 1, 2, 3, 4, 5. This one is an 8-sided figure. 1, 2, 3, 4, 5, 6, 7, 8. So this one is octagonal. Yeah. This one is 1, 2, 3, 4, 5, 6, 7. 7 is what? Heptagonal. So you have the triangular. So this one is a triangular prism. I can see the base here or the end. Okay. Oh, yeah. No, the base is the bottom part. The end. At the end is called the cross section. So let me just correct that one. The end is called the cross section. The base is the lower side, the side that it sits on. But then this side here, the ends are called the cross section. Okay. So let's correct that. Now, in this topic, we are only looking at regular solids. Okay. We're not looking at irregular solids. So this one is a pentagonal prism, like that one we can see in that particular case. So you can see this end here, or this cross section here is 5-sided, and then the others are made of rectangles. So this one is a 6-sided one, okay, like the one we have in that particular case. 1, 2, 3, 4, 5, 6. So this one is a pentagon, is an hexagonal prism. It's an hexagonal prism. So that is what we have. So we want to go and see how we find the surface area of all these prisms that we have here. Now, the prism that was in that particular share, I'll keep on running between the two because I need to have a working area and another area where I can be able to explain properly. So what I've done here in this particular diagram, what I've done here is you can see this part now. This part that I'm removing here is what I'm calling the cross section, and it is 6-sided. Okay, and if I put it here on this other side, on this other end, it fits perfectly. Okay, so it is going to be the same. So when you're finding the surface area, just find the surface area of this, and then you multiply by 2. Now, how do you find the surface area of that? How do you find the surface area of that? Now, probably I can do this part here, so I don't keep on switching a lot. Let me just come and put it here. I just copy and bring it here. I'm just going to copy and bring it here. Copy. Sound. I want to paste it here. No, why copy it? I think I've pasted the wrong one. This is the one that I'm copying. Let me see. I don't want this. So I wanted this. Now, then I'm going to enlarge it for the purposes of understanding. Now, it will look like this. Now, this one here, let me format it. I don't want it to have something inside, so I want it to look like that, okay? So as you can see, if you want to find the surface area of one of this, you require to just let me just show you. This is what I wanted to come and put here, to draw here. Draw a line from there. Not coming all the way to here. This part here. Okay. I draw another one. So I'm dividing this one into triangles. Okay. Now, when you divide a six-sided solid, you're going to get 6 similar triangles. 1, 2, 3, 4, 5, 6. You're going to get 6 similar triangles in this particular case. So in this case, you just find the area of one triangle, and then you multiply by 6. So how do you do that? So let's come here and see. We have been told here is something called theta. I want to delete this line. Delete this line here. So you can see theta where theta is. Okay. So we have been told theta is 60, radius is 6. So I'm going to show what radius is and where theta is. So radius is the distance from the center to the edge of this solid here. That is what is the radius. So from here, from the center to each of the edges, we have the radii. We have the radii. All these ones, they represent the radius. They represent the radius. And then theta is going to be found between any two triangles that we have. So we have theta here, then we have the radius. So I'm going to come here quickly and then insert a shape. Okay. The shape that I want to insert is a rectangular shape. Just to resemble one of those. I don't want it to have something. So the angle here is theta, and then the radius here we have 6. We have the radius here is 6, and then we have beta here. So, okay, let me show you how to find the area of a rectangle. Let me insert something here. So here we have it. We have that. And draw another one here. Now to find the area of a rectangle, using the formulas that we have, you need to name the rectangle. So this one is A, this one is B, this one is C. Okay, that one is A, B, and C. Now, these are the sides. So this is triangle ABC. Now we usually name the sides. What do I say naming the sides? That I name this side here. Okay, I also name this side here. The triangle has 3 sides. You have to keep on naming the sides. And then finally, I can name this last side here. Good. So now, when you want to name any of this, it is named using small letters. As you can see, the triangle is ABC, capital letters. But the side A, the opposite side of A is that. So we say this one is A centimeters. A centimeters. So you have to look at the opposite side. B, opposite side here, okay, is this. So for us to name this, we're going to name this one in small letters. And then you see this one is B centimeters. Not capital B. I just want small b. Then C, obviously the opposite side, this one is C centimeters. C centimeters. It should not be capital, it should be small. Not capital, but small. Okay. And this one you have A centimeters here. Not capital A again, I insist small a. Now, the angle here is 60 degrees. So the angle at C, this one here we have 60 degrees. 60 degrees, eh? The angle here is 60 degrees. We don't have the angle at A, and we don't have the angle at B. Okay, let's see. We have been told that the distance, this distance here. So this is the center. that C is where we have the center. So it's like I'm considering this. In this figure here, I'm considering just this part here. I'm not considering the others. So I'm just considering this. Okay, so I'm just considering this. So this distance of method is radius, and this is radius, which is equals to 6 centimeters. So as you can see, A is equals to, this side is here is A. So A now becomes 6 centimeters. A is equals to 6 centimeters. B is also equals to 6 centimeters. 6 centimeters. Now, so it makes this triangle here isosceles triangle. Isosceles triangle is a triangle where two sides are equal. Now, if it is an isosceles triangle, it means the base angles, the angle at A and the angle at B, they are equal. Angles in a triangle, they end up to 180 degrees. So we say 180 degrees, we subtract 60, we get the answer is 120 degrees. So 120 degrees, we divide by 2 because you have said base angles of isosceles triangles are equal. And then we are going to get that each of the angle there is 60 degrees. So the angle at A is 60 degrees. The angle at B is 60. The angle at B is also 60 degrees. So all the angles are equal. So it is not even an isosceles triangle. It means it's an equilateral triangle. Equilateral triangle means all the sides are equal. 6 centimeters, 6 centimeters, 6 centimeters. So all the angles are equal and all the sides are equal. Now, I'm going to show you two formulas of finding area of a rectangle. In this case, this one is better for far. No, not that one. Not that. So I want now to show you how to find the area of this using sine formula. So we have something called a sine formula, which is found by a half AB sine C. It's found by a half AB, small letters, multiplied by the sine, sorry, multiplied by this multiplied by the sine. The sine of C. So C is an angle. A and B are sides because you can see they are small letters. So sine formula is a half AB sine C. So A and B are sides. C is an angle. So the angle at C is 60 degrees. So in this case, you would say, instead of saying a half A times B, A is 6. So you'd say a half multiplied by 6 multiplied by 6 multiplied by the sine of how many degrees? The sine of 60 degrees. Then you get your answer there. So this is how you find the answer of the answer to this rectangle here. So a half times 6 multiplied by the sine of 60 degrees. So I can share something else. So I have a half is 0.5. Okay. 0.5 is here. So 0.5 multiplied by 6 squared multiplied by the sine of 60 degrees. The sine of 60 degrees is usually 0.8660. That is usually the sine of 60 degrees. So you get your answer as this, okay? 15.59 in 4 significant figures. So now, for example, we'll copy this answer and then you come and paste it on the other side. Copy it. I stop sharing the calculator. So I'll be requiring you to use the calculator at home. So I will not be sharing the calculator that time. So yes. So we come back here. So we were here. Yes, we were here. Were we here? No, we were not here. Don't think we were there. I think we were here. So the answer would be less. My answer is not pasting, I don't know what. So I can say 15.59. Good, it is here. So in 4 significant figures, it becomes 15.59. Okay. 15.59 centimeters squared. Okay. What we have just done here, we have found the area of one rectangle. So you multiply by 6. So we can come here now and then we multiply this one by 6 centimeters. Sorry, by 6 triangles that were here. And then because there are two, this was one of them. Remember there are two. So there is the front side and the back side. Then again, you also multiply by 2. You multiply here by 2. And then you get that answer. Multiply by 2. And then you get your answer there. Okay. You multiply and then you get your answer there. So this is supposed to be somewhere. And then you now come and then you add the, let me show you. You add the rectangular. Okay. So these rectangles are the same. They are similar. So we have how many rectangles? One. The two on the side. Top side 2. Bottom side 2. Those are 4. And then we have the top and the bottom. Those are 6. Okay. This distance here, remember you have said is the same as radius. So 6 times 15. 6 times 15 times 6. So you now answer. The answer that you're going to get here, if you get the answer A, you now add to the area of, sorry, now this. Now add to 6 multiplied by 15. 6 multiplied by 15 multiplied by, then you get your answer in centimeters squared. So it's as simple as that. This is how you can easily find the surface area of a prism. Surface area of a prism. So I think in those remarks, you can now be able to find the surface area of this prism here, which is pentagonal. Okay. And here it is in the shape of a house. Pentagonal. Just note the top here. The top here is right angled. So this top triangle here, when finding a surface area, just use half base times height. Okay. So you just find the area of this. So here the D, E is 4, D is 4 and 3. So half times 4 times 3. That's 12, 36. Plus this one is what? Is 20. So 26. 26. And this one 26. So 26. Then you multiply by 2. That becomes, gives you the answer. Then you find the area of D times C. Okay. B times C. Then you find the area of A times C. Then also there is other side A times C. Bottom B times C. Then that side triangle E times C. Then you get your answer. So in surface area of a prism, you just have to observe and then you just multiply, and then you add the various shapes that you have. Okay, let's move on. So we go to another share here. So this is what you have done, not this. Not this. Is a prism. Prism Frustum, not there. So this one. Yes. So this is how you do. This is how you do it. So that first one. This is how you do it. Okay. So I'm already calculated there. So that is how you do this. Now let us see volume. Volume of a prism. Volume of a prism is very simple. For example, this prism here now. You want to find the volume of this prism here. You just say cross-sectional area multiplied by, depends on how it is lying, okay? Multiplied by the height or through the length. For example, here we are going to multiply with a length of 22. But if it was not like this, if it was standing upside down, we would have multiplied, for example, this one here. Let me show you the one that we multiplied by the height. Like this one now, the way this one is lying. So you see, you are going to have this. So you're going to find the cross-sectional area, which is the area of the pentagon, 1, and then you multiply by the length. By the height, not this one is not the length, this one is the height. But if it is lying like this, you multiply by the length, okay? So that's why in this particular case, so like this, here you find the area of this, okay? And then you multiply by that, okay? Yeah. So you see when it's standing, so you can see the height now, but this one is the length. This one is not the height. So here you just multiply by the length, not the height. So I will just remove 8 here. So yes, so how would you find the area of this? So it is half times base, half you multiply by the base, which is 24, you multiply by the height, which is 7, and then you multiply by the length, which is 22, and then you get your answer in cubic meters. These are cubic meters, because as you can see, dimensions are given in meters. So it's as simple as that. Okay. So finding this one, finding the volume of a prism is very simple, and it's just the same with the cylinder, because this, I think, is one of the reasons why they say the cylinder is like a prism, because it's also cross-sectional area, because cross-section of a cylinder is circular, okay, or base area times the height. So cross-sectional area, okay, then you can now multiply by that other distance. Cross-sectional area, now multiply by the length or by the height, then you get your answer. Simple as that. So when it comes to the volume, I can see that volume, calculating the volume is just a very simple matter, but for the surface area, you have to do more calculations for that. Now let's look at another solid here. Let's look at another solid here. Solid called what? Look at a solid called a cone. Solid called a cone. Yes, this is a cone. So this is the one which is a cone. Okay, this one is not a cone. So this is a cone. This one is a cone here. In the cone, A cone and a cone has two shapes. It has the bottom circular part, and then we have the other, it is called curved part. So we have the curved surface area, and then we have the area of the base. The area of the base of a cone is a circle. It makes calculating that one very easy. It's a circle. Okay. Then we now come to the curved surface area. Okay, so we come here and so this one is not a cone, this one. This is not a cone, this one we call it a frustum. So I can cut and paste it somewhere else. Paste it somewhere else. I am placing the wrong thing. Then, okay, now let's it look like that. I think now it is better. So I'm now left with a cone here. So this is a cone. Now there are some things that you need to understand. This distance here, this distance that I've highlighted with blue here, this distance, okay? This distance is called the slant height. This is the slant height, which is abbreviated by L. This one is the perpendicular height, which is abbreviated by H. And this one is the radius. Radius normally we give it an R. As you can see, the perpendicular height and the base are perpendicular. They make an angle of 90 degrees. And if you add the slant height, they form a right angle triangle. So the examiner here is going to be, when testing you, the examiner knows that when you are finding the curved surface area, you don't require the perpendicular height. You require the slant height. But the examiner is just going to give you the base height and the base so that you can calculate for the slant height. Okay. Now, below here, this is what happens. So you can see this is a curve, this one is a net. So you can see this is a base, a circular base, and this is the curved surface area. So in this curved surface area here, you can see this is the perpendicular height, this distance here. This one is the perpendicular height. Okay, and this is the curved surface area, this one here. So they form an angle, they form a right angle triangle. You just combine them together. They just form a right angle triangle. Okay. So the examiner is just going to give you, if you're finding surface area of a cone, they're going to give you the height and then the base. So you use Pythagoras theorem to find, the slant height. Now, in this particular case, we are told that the base is the radius is 7 centimeters, and the height is 12 centimeters. So, okay, sorry, 13 centimeters. So the height is 13 centimeters, and the base or the radius is 7 centimeters. So you use Pythagoras theorem to to find that. So Pythagoras theorem, you know, is 13 squared plus 7 squared. You get the answer, and then you find the square root. So you get 218, okay? And then you find the square root of 218, get the answer in four significant figures, 14.76. So how do you find the surface area of such a cylinder? Now the base, we have said is circular. So to find the surface area of the base, you just have to use pi r squared. So it is pi times 7 times 7. And then to find the curved surface area, this is what you use. Pi times the radius times the curved, times the slant height. So it is pi times 7 times 14.76. And then you add the two of them, and then you get the answer. Now, some of the codes, like the ones that are used in birthday parties, they don't have the circular part. They don't have this. Yeah, it is open. That is, it is not closed. The circular part is closed, is open. The one that we use in birthday parties, the ones that are used, for example, in football training, they are open. Okay, but if it is closed, for a closed cone, this is what you use. So, circular base plus curved surface area. If it is an open cone, does not have the circular base, you just require to find the curved surface area. That is pi times r times l. Now, finding the volume of the cone is a very easy thing. So it is a third base area times the height. A third base area times the height. Base is circular, so you have a third pi r squared height. Okay, a third pi r squared, and then you multiply by the height. So, and then you get your answer in cubic units. You get your answer in cubic units. So finally, in this topic, I would like us to go to the last part. And the last part is this thing here that is called a frustum. We have this one called a frustum. Frustum is like a bucket, okay, or something we call a lampshade. This one is a bucket of water, and we have another one we call a lampshade. I don't know whether we have a lampshade here. I think we had a lampshade somewhere. This is a lampshade. So these two of them, we call them the frustum of a cone. We have a frustum of a cone, which is a lampshade and a bucket. Now, a lampshade, you put the lamp in between here. So that means it is open at the bottom and at the top. So you only have the curved surface area. So for the frustum, you only use the curved surface area. But for the bucket of water, you know that the top is open, but the bottom is closed. So when you're finding the curved surface area of a bucket of water, you require the curved surface area plus you add the base here. So that is what we're going to do. So just a moment, then we continue that. So we continue with the frustum. So a frustum, we have said we are going to look at the frustum of a cone. There's a frustum of a pyramid. So that one we are going to cover in another part, not this part. So a frustum looks like this, okay, or like what I've just done here. So it's in the shape of a bucket. So I'm just going to do an example here. Let me just So I want this. A bucket is the shape of a frustum of a cone with a top diameter of 28 centimeters and a bottom diameter of 14 centimeters. Its height, the height of the bucket is 10 centimeters. Calculate its surface area. Okay. So if the top diameter is 28 centimeters, then the radius is 14 centimeters. That is the top radius, which I'm giving a capital R. And then we have the bottom radius, which is a small r. That's that I'm finding using that is 7 centimeters. So capital R is the top radius, small r is the bottom radius. Now, capital L is slant height of the big cone. I'm going to show you what that one is. And the small l is supposed to be a small l. The small l is the slant height of small cone. Capital H is height of big cone. That's small h is height of small cone. So bucket ni hii. Let me show you where the bucket is. Here's the bucket. This one is my bucket here. Okay, here's my bucket. That's my bucket here. So I extrapolate. To extrapolate means I add a line. So you come and insert a line here. So for example, I've come and added a line here, okay? I come and add a line here, from here, all the way downwards. So instead of doing that, I just come and add this. So this one I think I don't create. So I come and extrapolate. So I'll do it, I'll do something like that. Okay. So this is what we call extrapolating. And this one. Good. So you can see now it is forming a cone. So this part that I've added here, so the bucket is a frustum. This part that I've added here, I usually call it a small cone. Okay. This part that I've added here is called a small cone. So this part here that I'm carrying here is a small cone. Now, when I add the small cone to the frustum, it forms a big cone or a full cone. So I'm going to have this. So for example, in here, I'm going to have this distance here, all the way from there to here. This one, I'm going to call it the slant height of the big cone. Big cone ni kutoka hapa juu mpaka hapa chini. I'm going to call capital L. And then there's this small distance here, this one. I'm going to call it the slant height of a small cone. So capital L and small l. I know what that means. Okay, then I'm going to have this one. This one I'm going to have to bring it here. Let me show you. This is now going to represent something that I call, okay, sorry. It's going to represent this. So let me take this distance here. This, I'm going to call it height of a big cone. This is the height of the big cone. From here to here. Let me just format it. That one now is forming the height of the big cone. So capital H. This distance here this distance here, you can see I'm adding here, is going to be the height of the small cone. It is a small h, the height of the small cone, the small h. Okay? And then the radius at the top here, the radius at the top here is going to be capital R, radius of big cone, and then the radius at the bottom here is going to be small r, which is radius of small cone. So I'm going to have big cone and small cone. I'm going to have big cone and a small cone. Now, like this case that I'm having here of this bucket here, you see? So the bucket here, we have said this one was 28 or 14 and 7. So let me, this example that I was using here, you can see it was 28 centimeters radius and 14 centimeters radius. So you can see this is radius, big R, okay? This is small radius here. So radius of small radius here is the bottom radius. Big radius is top radius of the bucket, okay? Then you have a slant height. You have the actual height. So you have the height of a small cone, it is here, okay? That one there. And then you can have the other height, which I changed. So this is the height of a small cone that is here. Then you can have this height here. It now forms the height of a big cone. Let me bring it here so you can see it clearly. So what is the height of the big cone? Okay. So height of big cone is this one. Height of small cone is this one. We have slant height of small cone, which is this one. Then we have radius of this radius here. A moment. So as you can see now, so we are going to have at the bottom here we have a right angled triangle. Now since we have height, we are going to have the height of a small cone and the height of a big cone. We are going to have radius of big cone and radius of small cone. But slant height you're not going to have. Okay? You're not going to have a slant height. So what we do is we come here and then we calculate using Pythagoras theorem. As you can see, slant height, base and the base and the height are perpendicular. So you can add the slant height, which they are going to form a right angle triangle. So you come here and you come and then you have a formula like this. You make the formula big. Now, so you say h, height of big cone over height of small cone. Here we don't have already. Here I've already calculated. Is equal to slant height of big cone over slant height of small cone is equal to radius of big cone over radius of small cone. So here I did not have this. So if I assume that the top radius is 28 and the bottom radius is 14, you just come here and you cross multiply. Now, height of the bucket is 10 centimeters. Now, if the height of the bucket is 10 centimeters, then this other height, you don't know it. Let me show you. This one here, this one I already calculated. So this small height here, you come and say it is x centimeters. So the height of the big cone is going to be 10 plus x centimeters. But the height of the small cone is x centimeters. So using that, it's called scale factor. You use scale factor. So you come and equate this 10 plus x over x. So this one is height of big cone. X is height of small cone. Radius of big cone is 28. Radius of small cone is 14. In that other example there, it was 14 and 7. So you would change that one. Okay. So for example, you come here and say 14 and the other one 7. So I have two examples. Sorry that I was using here. So you cross multiply. Now cross multiplying here means 14 multiplied by 10 plus x. Then x multiplied by 28. Where you have 14 times 10 is 140. Now 14 times x is 14x. So 14x was on this side. So here we would have plus 14x. Okay? And then here is equal to 28x. Now to solve for the value of x, you have to take the like terms together. That's why this 14x, it was taken to this other side of the equals, they became negative. That's why we have 140 is equals to 28x. So the answer is 28 minus 14x is 14x. So 140 is equals to, so finally here you are going to have 140 is equals to 14x. And then you have x is equals to 10 centimeters. Okay, x is equals to 10 centimeters. That's what I'm saying. H now is equals to x. So 10 centimeters, this is 10 plus 10, which is 20. So if I have that, I can now calculate the L and then this other the slant height here. So for the small part, height is 10 centimeters. And for the small cone, you have bottom radius as 14 centimeters. So you can use Pythagoras theorem. 14 squared plus 10 squared, you get slant height, supposed to be given by small l, not capital L. Small l is equal to 17.2 centimeters. And then you do the other case for the other, case where you say 20 squared plus 28 squared, and you get the answer is 34.41 centimeters. Now divide 20 by 10, 2. 34.41 by 17.2, 2. 28 over 14, 2. This is what is called scale factor. So we equated by saying that the big cone, the small cone is made, the big cone is made up of the small cone and the frustum. So they are similar. So they increase by a certain scale factor. And that is why you are saying H, this one capital H over small h is equals to capital L over small l is equals to capital R over small r. That is, if you compare the three measurements here, you are going to find that they are similar. So having found that one, you can now come here and then you find the surface area, and then you can find the surface area, and then you can find even the volume you can now find. So how do you find surface area? Now let's say this is what we have found here for bucket. For bucket, you're going to say curved surface. You are going to say pi. Let me just insert this. So I'm going to be using capital pi here, so that all of them can be capital. Pi r l minus space but minus pi rl. Those ones are for the big radius, minus pi rl. Pi is a constant, so even if I put a big pi, it does not mean that the pi is changing. Pi is always going to be the same. Pi is a constant, so pi is always going to be the same. So this is the formula that you have here. Pi rl minus pi rl. Why am I saying that? Let me bring you the bucket. You see, the bucket is going to be made of the curved surface area only. So this part here is mean worded. This part here has a small bucket here. This part here is mean worded. So the bucket is only made up of this. So you are saying curved surface area of the big cone minus curved surface area of the small cone is going to be curved surface area of the bucket. So to find surface area of the bucket, you say you have to require curved surface area of the bucket, which is this. So curved surface area of big cone minus curved surface area of small cone. And then because the bucket is closed at the bottom, you add pi r squared. So you add pi here. And the radius, remember the small radius is at the bottom. That's why you're using a small r. So you come here and add this. Total is pi r squared. And that is how you find surface area of the that's how you find the surface area of the bucket. Pi RL minus pi RL. That is curved surface area of big cone minus curved surface area of small cone, then plus the area of the base. And the base is circular. Okay. Now, if it was a lampshade like this, you would have done the same thing. But for the lampshade, it is now going to be easier because the lampshade is not the lampshade is open. So you just come here and then you extrapolate. Let me show you. No, what is not happening? So you draw this, you draw it up to there. Then I draw this. This whatever I'm adding here is a small cone. Okay. Yeah. So this what I'm adding here is a small whatever I'm calling a small cone. So I'm now going to say to find this, I have a bottom radius. Bottom radius is this. Let me show you how we find the bottom radius. Then I have height of this, capital H. Height is there. So this one is the radius here. So capital radius ndio iko hapo. Then you have a small radius. Because you can see now it is the shape yake is different. Its shape is very different from the bucket. Bucket tapers from the top to the bottom. This one is just opposite. So we have that. Okay, so this one is the height. This is the height of the small cone. The one that I'm adding here. Here. So it is one that I'm going to call x centimeters. And then because the lampshade is going to have a height here, the big height is going to be something plus x centimeters. Okay. Yes. So you just do the same for this. So for example, here we have been told that where is it? Radius, top radius is bottom radius is 15 centimeters. Top radius is R. Top radius is 10 centimeters. Height was at the 6 centimeters. Before that, let me see. H was what? That the 6 minus 24. Let me come because this one is already solved. So this one was 12 centimeters, okay? So originally this one was 12 centimeters. It was 12 plus x. Then this one was x. So you now cross multiply here. So you come here and then you cross multiply. So you, for example, you would come here and then you say, this is how you do it. Mhm. So here, for example, here it was 12 plus x over x. This is here over x is equals to 15 over 10. Then you cross multiply here. When you cross multiply, you're going to find 10 multiply by this, whatever is in the bracket here, 12 plus x. Okay, is equals to 15 times x is 150. I will come down here and then you see this is 120x plus 12x or plus 10x, sorry, is equals to 120. This is not 120x. This is 120 plus 10x is equals to 150. Okay, 150x. 12 times this one 120 plus what? 120 plus 10x is equals to 15x. So yes, so you take this x here, so you say minus 10x, 10x. Come here, you say minus 10x. So you have 120 is equals to 5x. Okay, and then you get x is equals to 120 divided by 5. I think is equals to 24. So x is equals to 24 centimeters. Okay, that's why now you have this one 12 plus 24 being 36, and then this one is 24. So now this here is 24, and this one is 36. So to find that, so you have found the value of x. Yeah, that's why I find the value of x. So I came here, the top radius 15 and height 36. So 36 plus 15 squared. So you come here, you form a right angle triangle. Let me show you. So after finding that, you now require to come and insert a right angle triangle here, and then use Pythagoras theorem. So this is my right angle triangle. And then we enter this. I need to make this one bigger. Then I rotate it so that we can look where I want. There you are. Okay, so I have the height. So for example, if this example here where the height is at 6 and the top radius is 15, so I say 36 squared plus 15 squared, I get this one as 39 squared, and for the bottom case is 24 squared plus 10 squared. So I have 24 squared plus 10 squared, I get this one is the slant height is 26. And then I can now proceed by saying pi RL minus pi RL. So pi times 15 times 39 minus pi times 10 times 26. You get your answer in this. Remember this one, the top and the bottom are not are open, so you only find the curved surface area. So you only find the curved surface area. Okay. This is how you do. So that's how you find the current surface area. It's as simple as that. Then you get your answer. Then your answer, now you can be able to move on and calculate all of that. So that is how you find the surface area of a frustum. And so in the next lesson, we are going to be looking at the surface area. Let me come to the volume. Now, volume, I was forgetting, volume of this one is very simple. Okay. Now, having these measurements, volume, we just do volume just normally. Remember, volume of a cone, so the volume is going to be very simple. Volume of frustum is equal to volume of big cone minus volume of small cone. So you say volume of frustum is, you come and insert this formula, these fractions here. Now to find the volume of a cone is a third I'm going to use R H. A third by R squared H. This is R squared. So R squared. Then I see here minus. Then I have another third. Then I come and insert my pi here. R squared H. So you can see I'm using capital H and small h. This is R squared. I don't know whether it is going to give me that because once it is inactive. So let me just put R times R. So you understand this. Here, R times R. Sorry, this capital R and H. So these are multiplications here. We close the bracket here. Close it here. Close this one. And then we open this bracket. And close it here. This is multiplication. So very simple. Yes. So this is how you find the volume of a frustum. Whether it is a bucket or it is a lampshade. But for lampshade, actually, there's nothing you can put in the lampshade. Okay. Yes. But in the buckets, you can put something in the bucket. You can put flour, you can put sugar, you can put water, because you have seen the volume is the amount of space occupied by a solid object. Not that you cannot calculate the volume of a lampshade, frustum is a lampshade. No, it is the space that is in between those confines of that frustum. So this is how you do it. So pi, so volume of big cone, so use capital R and capital H, and then use small r and small h. For example, here R was 15, this is 10. So here I would have used 15 in the first case. I would have used 15. This one here and use 15. This one is 10. If I'm not wrong, this is 10. This is 10. And then height was 36. Then this one is 26. 39, sorry. 39. And this one is 26. Pi is a constant. Okay. Pi is a constant, so it means Nothing else changes there. So for this second example, this is how you have done it. And then you get the volume. Remember, you get the volume in cubic units. And then if it's a bucket, can be done to convert in meters into meters squared and all those other cases. So that is what we have. Did I share that? Oh, sorry. Let me share that. Whatever I've just done here. Sorry, Sharon, I was not sharing that. Is it? Or I was sharing? I was sharing. Yeah, this is what I was doing now. Volume over frustum is equal to volume of big cone minus volume of small cone. Okay. And I've said, like, using this example here, volume of cone is a third base area times the height. A third base area times the height. So it is a third times pi. Base area is a third pi. A third base area, a third times pi r squared. Okay. A third times pi r squared. And multiplied by the height. The two heights, pi r. Sorry, here I'm just giving you the wrong thing because this is 36 and this is 24. Because for a cone, it is pi r h. Hey, 36, this is 24. 24, yes. 36 and that is 24. It is the third base area times the height. So volume of a cone, so volume of a frustum, you get it from volume of a cone. Volume of a cone is equals to a third base area. A third multiplied by base area multiplied by the height. Okay? Yes. Curved surface area nimetafuta na hiyo nyingine. So this is there. So this is that. So surface area is what you use pi r l. Examples of surface area, I think we are done them down here. Pi r l, yes. That's why we are using this one. Pi r l, that is volume of big cone minus volume of small cone. Pi r l. But when you are saying, when you're finding the volume is pi r h. So that base area times the height. And that base area times the height. That base area times the height. Perpendicular height, not this is perpendicular height h, not slant height l. Slant height is only used in a code for curved for the curved surface area, and is only used only to find the surface area. But for the perpendicular height, we use it to find the volume. The volume for that base area multiplied by the height. So I think that is what we are going to do for today. And then next week, we are going to continue with the rest. Now, Sharon, did you do my assignment? Because I sent you an assignment for the topic of probability. Did you do that? Sharon? Sharon?
I tried doing it.
Yes.
No, I found the one which you sent before.
Yes.
Can you hear me?
I can hear you, yes.
I found the one which you sent earlier, but this other one, I've been trying to open it. It's saying that it's not found. It's not there on the dashboard.
Because at the time for submitting the assignment is past, as it's already over. Yeah. I'm going to send that assignment again today, and then I'm just going to change the timeline. You do it immediately right now. Just go and do that assignment, because even here I'm supposed to be giving you assignment for these topics that you have been doing here. So that I get I'm able to understand how you are doing your progress. I can know that whether you your level of understanding, and then I can know whether to move on or just to insist on something. So right now I'm just going to share that one with you. This video is going to be sent on YouTube. I'm going to be sending the link after I download it. I'm going to be sending the link on DS. And please tell your friends to be very serious with your work, because I don't think they are being serious. So we are going to meet next week. It was good having you. So see you next time.
Okay.
You are currently the only person in this conference.